Hello everybody, my name is Chun Lu from the Budapest University of Technology and Economics. Today in this video, I'm going to share with you my work on the implication of user and system optimum based traffic control, considering the autonomous fleets. The overall purpose of my research is to make a better usage of the existing infrastructures. And this work is related to route assignments. As we all know, an accurate transportation forecasting is important to an efficient traffic control on traffic lights to reduce the waiting time and queue length at the intersections. Transportation forecasts have traditionally followed the four-step models. The route assignment is the last type of four-step model. Trip generation determines the frequency of origin and destination of trips in each zone by trip purpose. Trip distributions match origin with destinations. Mode choice compute the proportion of trips between each origin and destination that use a particular transportation mode. Route assignments allocates the trips between an origin and destination by a particular mode to a route. Often, the Waldrop's principle of user equilibrium is applied. What is Waldrop's principles? Let's take a simple example. In this two-route map, the vehicle should travel from A to B. There are two ways to determine which way to take. First is the user optimum principle. In this case, the journey type in all routes actually used are equal, and it can be expressed in mathematical way as this. In this formula, it is assumed that the free flow travel time on route 1 is less than the free flow travel time on route 2. When the demand is less than V prime, all vehicles take route 1. When the demand is bigger than V prime, the route assignments will make sure that the travel times on both routes are equal. Another principle is so-called system optimum principle, which it makes sure the average journey time is at a minimum. As we all know, as the development of information technology, the connected intelligent transportation system makes the use optimum possible because the driver can get the traffic information on the routes. They can take the fast way to their destination, while the system optimum is not that well studied. But with the spread of mobility as a service and the robot taxi makes the central control of route assignment possible. Besides, the congestion pricing is also a way to realize the system optimum principle. The volume delay function is the theory foundation of Waldrop's principle. As shown in this slide, the first formula is the VDF of traditional vehicles. The second one is the VDF of autonomous vehicles. The difference between these two formulas is that the VDF of autonomous vehicles considering the impact of autonomous vehicles on route capacity. As you can see, a new parameter is introduced to consider the formula to consider the impact. In this work, the parameters are chosen as follows. The curves of these two formulas is shown in the picture. The x-axis for the demand, y-axis for the travel time, and the cross point is the equilibrium point for user optimum principle. What happens when it comes to the system optimum? The split will be earlier. Let's have a look on the calculation results of 3 scenarios in the paper. When demand is low and high, there's a little difference between these two principles. The system shown its advantage when it comes to medium demand, which is also very common in reality. The next scenarios is for pure autonomous vehicles. The travel time becomes less and the difference range prolongs. The third scenario is when we set the free flow travel time equal. The two principles shows no difference at all. In order to make the difference clear, the travel time difference between two principles in 3 scenarios are drawn in one picture. As you can see, the travel time difference of autonomous vehicles appears later and prolonged compared to that of traditional vehicles. And the max difference is around 1 minute, which is around 10% of the travel time. In addition, the sensitivity analysis on road capacity is investigated. As we can see in the diagram, with the increase of capacity of Route 1, the difference range and slope become wider and gentler. The maximum travel time difference shows a decreased trend, but almost keeps the same. There are 4 findings in this work. The system optimum principle makes the transportation system perform better in terms of average travel time. Wardrobe's 2 principles are equivalent if the network has the same free flow travel time on each route. The autonomous vehicles fleet running in the traffic system will dramatically drop the average travel time on both routes. The increase in capacity enlarges the difference between yield optimum and the system optimum by prolonging the different range and slope. In the future, a more complex road network will be used, and we are also going to try to obtain the system optimum by congestion pricing. Thank you all for your attention. If you have any question, you can comment below or write an email to me. Thank you very much.